Hello students, this is Varun. By now we are well aware about the term polygons. We know that a polygon is a closed figure which is entirely made up of line segments. We have studied about different kind of polygons depending upon the number of sides that they have. We studied about triangle, which is a three-sided polygon. We have studied about quadrilateral, which is a four-sided polygon, pentagon, which is a five-sided polygon, hexagon, which is a six-sided polygon, and so on. We studied about their properties as well, particularly about triangles. We studied various properties of triangles, and even today we are going to discuss one more property of triangles. And this property of triangle is concerned with the midpoints of sides of the triangle. Like if we have a triangle and if we join midpoints of any two sides of the triangle, then the line segments of formed is related to third side, and today we are going to discuss that relation, and that relation is given by midpoint theorem. And midpoint theorem states that the line segment joining midpoints of any two sides of a triangle is parallel to third side and is half of it. For example, if we have a triangle ABC, where P is midpoint of side AB and Q is midpoint of side AC, and if we join point P to point Q, we will get the line segment PQ. Then according to midpoint theorem, PQ is parallel to BC and length of PQ is half the length of BC. And today we will do proof of this midpoint theorem. So first we mention the things which are given to us. We mention in triangle ABC, P and Q are midpoints of sides AB and AC respectively. Then after we will mention the thing that we need to prove, and to prove is PQ is parallel to BC and PQ is half of BC. This is what we have to prove. Well students, for this we have to do some construction. We will draw a line parallel to AB passing through point C. So here we have drawn CL, which is parallel to BA, and we have to produce PQ to intersect CL at a point, and let this point of intersection is R, and we have to mention this thing as well. And we mention the same under construction, that draw CL parallel to BA and produce PQ to intersect CL at point R. Now after this we start with the proof. Well students, for proof we considered the shaded triangles AQP and CQR. We can see that in these two triangles, these two angles are equal, they are vertically opposite angles. Then after AQ is equals to CQ, because it is given that Q is midpoint of AC. Then after this angle and this angle, they are also equal because BA is parallel to CL and AC is transversal. So these two angles are equal, they are alternative interior angles. That is why we can say that triangle AQP is congruent to triangle CQR, that is by ASA congruency criteria. Now let us mention the same. So here we mention that angle 1 equals to angle 2, vertically opposite angles. Then after AQ equals to CQ, because Q is midpoint of AC. Then after angle 3 is equal to angle 4, because they are alternative interior angles. So we can say that triangles are congruent by ASA. Congruency criteria. Since these two triangles are congruent, so we can say that PQ is equal to RQ and AP is equal to CR, that is by CPCT. Let this be 1 and this be 2 respectively. Also it is given that P is midpoint of AB. So we can say that AP is equal to PB. So here we mention the same, that AP is equal to PB. Let this be number 3. Now from 1 and 3, in equation number 1 and third one, we can see that both CR and PB, they are equals to AP. So they must be equal to each other. So here we mention that from 1 and 3, we can conclude that CR is equal to PB. So students, by now we have proved that length of this PB is equals to length of RC. Also from construction, we have BA is parallel to CL. If BA is parallel to CL, then BP is also parallel to CR. It is because parts of parallel lines are also parallel to each other. So now we mention this thing, as BA parallel to CL, so BP is parallel to CR, and the reason is parts of parallel lines are parallel to each other. And let this be number 4. And where we proved that CR is equal to PB, let this be number 5. Now from 4 and 5, we can see that BP is parallel to CR and BP is equal to CR. Again, BP is parallel to CR and BP is equal to CR. Since in quadrilateral BCRP, one pair of opposite sides, that is BP and CR, they are equal as well as parallel. So we can conclude that BCRP is a parallelogram. So here we write from equation number 4 and equation number 5, BCRP is a parallelogram. Now BCRP is a parallelogram. So BC is parallel to PR and BC is equal to PR, because we know that in a parallelogram both pair of opposite sides are equal as well as parallel. That is why we can conclude that BC is parallel to PR and BC is equal to PR. So here we mention the same, that BC is parallel to PR and BC is equal to PR. Also we know that parts of parallel lines are also parallel to each other. Since BC is parallel to PR, so BC is also parallel to PQ. That is, we mention that BC is also parallel to PQ. Also from equation number 2, we can see that PQ and RQ are equal. Since PQ and RQ are equal, so we can write PR as 2 times PQ. So here this BC will remain as it is, but PR should be replaced by 2 times PQ, and the reason is from equation number 2. In next step, we can further write that BC is parallel to PQ as it is, and when we shift 2 to left side by cross multiplication, we get half of BC is equal to PQ, or this whole can be written as PQ is parallel to BC and PQ is half of BC. This is what we had to prove. So finally we write hence proved. So students, in this theorem we have studied that in a triangle, the line segment joining midpoints of two sides of a triangle is parallel to third side, and this line segment is also half of the third side, which we just have proved that PQ is parallel to BC and PQ is half of BC. And students, this proof of midpoint theorem, this result of midpoint theorem can be used in a lot many questions related to different kinds of polygons. So today we end here only, and in next video we will discuss about converse of midpoint theorem. Thank you.